Today's lesson is going to be about level design and materials. Let me share the screen here. Can you guys see the slideshow?
Mm-hmm.
Okay, cool. So like I said, level design and materials. So since we were a little behind on the scheduling, these aren't going to be pre-lesson materials, so I wasn't expecting you guys to watch these videos for today. But after this lesson, if you would go ahead and check out those two playlists that are linked in the GitHub. One goes into about like an hour of level design, just different things. We're going to be touching on a lot of that today, but goes into probably a little bit more detail and just a lot of the different aspects. And then the second playlist is going to be Intro to Materials. So this one's going to be doing a much deeper dive on what we'll be doing today. We're going to be talking about how to create materials, what exactly a material is, the different components, kind of usability things. But this playlist will go kind of into more detail, as well as some how to use it in blueprints as well, and how to create dynamic ones using blueprints. So definitely check out that playlist. But the first thing that we're going to talk about is the levels and what exactly is a level in Unreal. And essentially a level is kind of just a collection of a lot of different assets, blueprints, as well as different engine content like lights and volumes that are just housed inside of one singular area. And essentially, if you've played, any video game that has multiple levels, each of those levels is separate from another one, so all those assets are different. The level blueprints are separate, so you can house specific functionality that interacts with each of those different pieces of that level specific to that level. Another part of the level design is, Daniel talked on this before with one of his previous lessons, where it is talking about the world settings, as well as game modes and stuff like that. Those can all be adjusted per level basis as well. Now we're going to jump into kind of like a little bit of the theory behind what a material is. Now this can be a really complex topic because there's just a lot of information that is kind of needed to understand in order to get a really good grasp on what a material is. But essentially in the tutorial series that I linked, Zach Parrish describes kind of a material as almost like a set of paint that you can apply to something, any sort of mesh, and that paint kind of adjusts how it looks in the world. So it might be a little shinier, it might be kind of rough, it might have kind of like some bumps, texturiness to it, that kind of thing. But in reality, what a material is a surface that adjusts how light reflects and light bounces off of an object that it has the material attached to it. So, but like even more specific of what a material actually is it's a collection of textures and instructions that define what's called a shader, which ends up rendering out pixels on your screen based off of those instructions and what the material is telling it to do. So textures, if you're unfamiliar, are essentially 2D images that can be either color or black and white, depending on the type of map. And essentially they control specific aspects of a material. So we'll have like a texture that handles the color of a material. We'll have a texture that handles the roughness of a material, which is essentially how glossy or how rough the surface is. So how much light it actually reflects. 0 being perfectly glossy, meaning it reflects all the light perfectly, and 1 meaning it reflects no light at all. Another one for normal map, which determines how, now a normal map in itself is a very, very complex topic, and we can go on like a whole lesson about just normal maps, but essentially a normal map handles, it's an RGB color map that handles how light reflects after it hits the map. So essentially what we use normal maps for in games or in things like an Unreal Engine, is to kind of fake detail and create shadowing that wouldn't otherwise be there. That's the most simplest way to explain what a normal map is, but it'll make a little bit more sense when we go into it a little later and I show you what it looks like. And then another map for metalness or metallic. And essentially, it's how metallic an object is from 0 to 1, 0 being not metallic at all, and 1 being perfectly metallic. And I think that's all the maps that make up a physically based rendering system. There are other maps, and when we make a material later, you'll see like there's a lot of different channels that we can attach to, but those are the 4 primary maps that are used for making any physically based rendering material. And then a shader is, again, that's another extremely complex topic, but the simplest definition of what a shader is it's what your graphics card uses to render out the pixels. And so essentially when we're using game engines, we're using materials that kind of house a lot of this information, similar to blueprints, how we have these nodes that are kind of the underlying piece of those nodes is like C++ programming. When we're making materials, a lot of the nodes that we'll be using are HLSL, which is a shader language, similar to kind of like a programming language that talks about you know, these different functions and stuff like that. And essentially a shader reads that material and then just, you know, determines what it needs to render on your graphics card. And again, I kind of talked about this already, how they all relate to each other, but material is made up of textures, and then a shader uses that material. Essentially, it's the definition of all of that. And then for using materials in Unreal, we'll be talking about this and how to use them, but essentially an important thing to know when materials is different game engines and different softwares use different material systems. So I believe for a while, Unity was a specular glossy material system, which means they're not physically based rendering, which means they use specular maps, glossiness maps, as well as some other ones. Whereas in Unreal, we're using physically based rendering, which is supposed to be as accurate to real light simulation as possible. So we're using the roughness map, the normal map, etc. So that's just an important distinction to know. Also, when you're buying assets, and I believe we talked about some of this for some of you guys for the your Lenovo projects, but you need to make sure that whatever assets you're purchasing, and if you're buying textures that come with those assets, that you're buying them for the correct type of material system. So a lot of times if assets are made in like 3ds Max or something like that for Unity, the texture maps they might be giving you are different than the texture maps you need for Unreal. So that's just something to keep a note of, and just make sure that when you're buying assets, make sure that it's PBR friendly or physically based rendering, because that'll import into Unreal perfectly. Okay, so let's go ahead and get started with the tutorial real quick. Do you guys have any questions so far about the brief little bits of information? Okay. Can you guys see that okay? Okay. So the first things first, let me import this cube here that I made earlier. And if you're unfamiliar with importing, you can simply just grab your asset from your file directory, or you can click this import button right here and then navigate to wherever it is and import it. Same thing with textures. I've already dropped these ones in, but all you have to do is the same thing as dropping in an asset. And we're gonna go ahead and just import. Now I imported this with these materials, and we'll see why in a second, but one of the first things with materials is these things called material slots. Let's make this a little bit bigger so it's easier to see. But this is really important for when you're building levels and you're wanting to use multiple different types of materials on the similar object or a same object. Now, over here on this right side of the panel here in your detail section, in the material section, we have these element 0 and element 1. Now, essentially, these are different material IDs that are applied to the same static mesh. And what this means is that we can apply two different materials to the same static mesh. And it applies them in the different positions based off of whatever we have determined in our UV set. And I'm not going to be talking too much about UVs because that kind of goes into more of the texturing side. This will be more about how to create the materials once the textures are already given to you in the assets. But essentially on the 3D authoring software side, we can kind of determine how we want materials and textures to be applied to an object. And so in Maya, I essentially just took a couple of the different faces and I applied a different material to basically the three different sides. And what that has allowed me to do is when I import that, Unreal reads that separate material slot in and allows me to drop in a new material on that slot. Okay, so next I'm just going to show you how to create a material really quick. You can just right click here in your content browser and click material. I'm going to name this M_S material. And essentially what we're going to do is I'm going to create two materials here. Test, actually here, you know what, instead of doing that, I'm going to create an instance material of the first one once we have the first one created. So what I'm going to do now is just open up our test material, and I'm just going to move this up here for a second. And then what we're going to want to do is move in our textures that we have created and hook them up into our material node. So this node right here is essentially the result for our material. So this is what actually tells the material what it needs to look like. And we can hook in a bunch of these different nodes over here. If I move this over here, these are all different either mathematical nodes or color nodes and stuff like that. Kind of similar to how blueprints have this whole library of nodes that you can call from. These are all the different material nodes. There's a lot of really, really complex ones. Some of them are functions as well, which are kind of just a collection of nodes. But we're not going to be using too many of those. So I'm just going to grab the materials here, these first ones, this material 1. You can select all of them like that and just drag them right in. Alternatively, if you didn't want to drag them in, you can right click somewhere and type in texture sample and select the texture sample node, and this will give you this blank node here. And then we can determine which texture we want it to be. So if you have a texture selected, like I did here, it'll grab the first one you selected, which for me was this base color one, and it'll automatically have that texture sample populated. But you could change it if you wanted to, just like that. And it'll give you a little preview of the node. But again, when we're making materials, it's really important to understand the different maps we have and what the different maps are. So it's also really important to make sure that your naming conventions for your textures are something that is usable and understandable. So for me, I like to name my materials, I just give them a short abbreviation. So base color is BC, normal map is N, and then roughness map is R. Now, occasionally, if you're using something like Substance Painter, sometimes your texture map might be combined. So some of your black and white maps, because essentially a color map is made up of 3 channels, right? R, G, and B. So red, green, and blue. And each of those channels is actually a black and white channel. So if you looked at just the red channel or just the green channel, it would actually show as black and white. But when they're overlaid on top of each other and you have the red plus the green plus the blue, it creates that color that we're familiar with. But like I was saying, if you're using something like Substance Painter to create like your roughness map, occasionally we might be using something like ambient occlusion or your metallic or your roughness. It'll combine all of those 3 different maps into one singular map called an ORM. So occlusion, roughness, metallic. And so that's just something to make sure that you're keeping a track of. If your map is an ORM map, essentially, instead of using the full RGB color, you will just be using a singular channel. And I believe for if you're using Substance Painter, blue is metallic, green is roughness, and red is ambient occlusion. But we're not using that right now, so we'll just go ahead and hook it up normally. So base color goes straight into base color. You hook them up just like you would nodes in Blueprint. The normal goes into normal, and then the roughness goes into roughness. I can move these around a little bit. And then it'll give you a little preview of the node here. We'll just apply. And then save. And then we'll go back over here into our level. And now we can take this new material that we've just made, and we can apply it over here in one of these material slots. And it will replace the previous one. Or we can drag it out into our world and kind of place it over the material we currently see. So just like that. Okay, now I'm going to create a material instance. So if we go back over here into our material node, we can select these textures here and right-click them and convert to parameter. Now, this is similar to, again, with blueprints, where essentially we can create instanceable parts of a material. And what we're going to do is call this the base color map. And then we'll call this one the roughness map. Oops. Okay. So another thing, when you're saving your materials and you're making these, the apply button changes the material and all of its uses in the current world, whereas saving does not always do that. Saving will just save the asset. When you apply something, that does not mean it is saved. So if you crashed after you've applied it to all the objects in the scene, you would actually lose the information you've done after that. Okay, so now that we have, cancel that. Now that we have the material set up properly, now we can create a material instance by just right-clicking that material. And it'll create an instance of that material. Now this is really important because one, this is really nice for making variations for materials. So let's say you were using like you had a lot of shader code in there for like changing the height of bricks or something like that. And it works really well based off of normal maps and stuff like that. And you didn't want to have to rewrite all that over and over and over for every different type of brick that you were creating. If you made an instance material and you just made it all instanceable, you could just very easily swap out those maps and reuse that you know, all that functionality you already have in there. This is also really important because in terms of performance, material instances are actually extremely more performant than regular materials because it's having to do less of the draw calls because they're already there. It's just instancing them. Okay, so now we can open the material instance by double-clicking it. And again, it's going to look a little different than a regular material because you do not have access to changing a material instance from the shader side. You can just swap out the different, you know, parameters. So you could put in like different like number parameters and stuff like that and change values that way, but you cannot change the actual functionality of how it performs. But we can now just change these different materials, these maps, to these other nodes here. There you go. And you can see on this map, I have this applied. I drew on it a little bit to kind of try to demonstrate some of these different maps in action. Let me find the directional light here. Okay, there we go. So you can kind of see when the light is shining on some of these areas here. So essentially I have adjusted the normal map here to create this kind of what's supposed to look like an indented area and then a raised area on the surface of this object. Now this raised surface or indented surface is not actually there. It's completely flat. But this is kind of what a normal map does, is it kind of fakes the illusion, it gives you the illusion of depth based off of just creating these shadows around parts of the object. You can also see that when the light is shining on the top of the surface, it's perfectly reflective. But on this area of the surface, it's only partially reflective, and we're kind of seeing that kind of like grime and stuff like that. So essentially on the edges of the surface here, this is probably about a 0 in terms of roughness. And as we move closer to the circle, so right in here would be a 1 roughness. So we cannot see any light reflecting off of the center of the object here. And then kind of halfway through, we kind of get like a little bit of reflectivity along some of this area that isn't a 1. But essentially, those are the different types and the different parts of maps. And then obviously, base color is just the color. If we go back to this material node, there's a lot of different ways that you can make different materials and different effects and stuff like that. There's a lot of these different nodes that are also grayed out. And essentially what this means is that different types of materials based off of the blend mode and the shading model are not accessed because they're not usable or not required. So for an opaque material, meaning you cannot see through it at all, these are the only maps you're allowed to use. So we have specular, metallic, base color, roughness, emissive, normal, world position, ambient occlusion, pixel depth offset. A lot of these types of or parts of the material you will never use. So the only ones you really need to worry about are base color, metallic, roughness, normal, sometimes emissive, sometimes opacity, and then sometimes ambient occlusion. But in order to get and use something like opacity, we'd have to change our blend mode from opaque to either masked or translucent, depending on whatever our use case was. So if we were making like a fence, for example, like let's say we had a static mesh of like just a rectangle, but we wanted to give it the illusion that there was like a fence texture on that object. We could use the masked blend mode and then feed in a black and white image to determine what parts of that material would be masked and occluded and what parts wouldn't be. And we could simply just plug that into the opacity mask. But for the purposes of this, I don't think we really need to go that far. And I'll just go ahead and get started on building out a level from scratch and some of the different things that you want to do. So first thing, I'm going to just right click in here and create a new level. We'll just call this test level. Okay. So when we first create a level, it's going to be completely blank. So the screen's going to look black. That's normal. We just need to add some stuff in here like lights so that we can actually see what's going on. So the first thing I usually like to add is the directional light. Oops. And then some atmospheric fog. And as soon as we drop this in, you'll see we can actually start seeing around a little bit because it gives us that ambient light. And then let's grab some floor here. Now, since I used a completely blank project here, there is no assets on the content browser side that I can utilize. So if I typed in here like floor, like that template floor, that's in like pretty much every template, it won't be there. But if we want to add in content packs, we can go over here and hit add new, add feature or content pack, and we can select one of the templates that you have access to when you're first starting your project. So I'm just going to go ahead and click like the third person one. So I know that it'll give me access to all these different assets like the floor and the wall, as well as the blueprint sky sphere as well. So we'll just add that to the project. And then I'm also going to add the starter content. And this gives us a whole collection of materials and basically a lot of just materials and some static meshes and floors and walls and doors and stuff like that. Yeah, I believe this is what has access for the previous door tutorial. The starter content is where that is accessed. Okay, so now that we have all these folders, it'll just automatically add them in here. Now, if I type in floor, I can find that template for. And an important thing when you're building out a level from scratch is to make sure that you know where your relative location is in the world when you're first starting out. Because right now I just dragged this out and it placed it at 770x, 50y, and negative 20z. But we may want to put this at 0, 0, 0, just so that we know exactly where we are, and we're not just out in the middle of 5,000 units or something like that. Because that's important to know for if you're wanting to spawn in an item or something like that. You're going to have to spawn it in at whatever relative distance you are from where you started. So if you're wanting to create I don't know, if I wanted to spawn in some doors or something like that, you want to make sure that you're somewhere near 0, or else I'm going to have to find out wherever we currently are, so 5,000 units to the right or something like that, and then spawn that door 5,000 units to the right. It just gets messy. Anyways, you'll notice that the first thing, you're gonna get these little error messages up here now that we have this lighting in here and we added a new object in. Essentially, this is saying that the lighting needs to be rebuilt. And what that means is that we've added a new object and the lighting is no longer accurate and the shadowing is no longer accurate. So the way lighting works in Unreal, if you're using static lights, so I guess one thing is there's different types of lights depending on those different types of lights. So there's static lights, movable lights, which are dynamic lights, and then stationary lights, which are kind of semi-dynamic. And essentially, those different types of lights determine how shadows and lighting is rendered. So static lights mean that all the shadowing is baked onto the textures and the shadow maps. So whereas a dynamic light is it's constantly checking and it's constantly rendering and it's constantly checking all those shadows in real time. So since our light here, if we go to our directional light, right now it's set to stationary. If we change this to movable, that little error message goes away because we no longer have to worry about rebuilding those shadows and that lighting. But if you were, I guess an important thing to know about lights is, real-time rendering of lights is very expensive. And so there's a reason that we use static and stationary to bake lighting. It's significantly cheaper. So when all possible, it's much, much, much more efficient to just use static lights and then bake that in. And in order to bake that lights and to rebuild the lighting here, we go up here to this build button and we can either build everything in the entire level. So this is, it builds reflection captures, it computes visibility, it builds geometry, it looks at navigation paths, texture streaming, if you have any automation and stuff like that. We don't have any of that and we don't care about checking any of that. So we're just gonna build just the lighting. So you can click this little arrow and then click just build lighting only. And it'll take a little bit. If your scene is really large and you have a lot of materials and you have a lot of different stuff going on, it'll take significantly longer. But once that building is done, it will also create this build data in your levels. Now you generally won't see this anywhere, but it'll kind of be this hidden asset in there. But essentially, there it is right there. That just keeps track of all the lighting and the of that specific build data. So just that lighting information. Another thing is, I don't really like seeing this grid, especially when it flickers when you have something placed right on top of it. So you can get rid of that by going over here to the show and go down to grid. It's also important with level design, using this different show menu to kind of look at different things or hide different things. Sometimes when you're using things like particle systems, it can be hard to click things behind the particle systems because they might create these big, moving planes. make it very difficult to click through. And so you can adjust, if you're trying to click on something specific, you can like remove your particle sprites, or if you just wanted to see what your navigation looked like, but nothing else, or if you want to look at your collision, there's different things in here that you can check and just show. Okay. So next thing, let's start adding in some more assets here. So like I was saying before, there's two ways that you can add in assets, either from your content browser or from the modes panel over here. Now, if you're using a new version of Unreal, so like 4.25 or 4.24, I believe, this panel will probably look a little differently. You'll have your details panel, and then your modes panel will probably be up here in the top left, and it'll say something like, I don't know, I forget what it's called, but it's essentially like actors and assets and stuff like that. If you're missing it, you can just go up into Windows and go down over here into editor modes and then grab that modes panel. Again, it's going to be called something different in the newer versions of Unreal, so just keep that in mind, but it'll still be there. Now, the modes panel in the earlier versions is made up of several different parts. So we have the place, so place assets, or actors or volumes and stuff like that. You have the paint, which is used for vertex painting. So that's another complex topic, but essentially we can paint on textures and stuff like that based off of geometry that we find in the scene. We have our landscape tool, where we can create, big giant landscapes and kind of sculpt them to create our world that way. There's foliage, and then there's creating a geometry from scratch. You probably won't be doing any of these right now. I think we'll have some lessons later on where we go into like landscapes and foliage and painting, that kind of stuff. But for right now, we're just going to use the placing simple assets. And it's just as simple as clicking and dragging them out. But a really important thing is if you're using assets from the modes panel over here, these are not blueprints. You cannot access these from a normal blueprint. These are just editor actors that are just placed into a level. If you want to access these different objects, you'd have to select them and then go into your level blueprint and then reference them from there. So create a reference to cube, and then I could do whatever I wanted from there. But this is only usable for that specific level. So it's really important that when you're building levels to kind of understand if you're wanting to use assets across multiple levels, make it a blueprint. Or make it some sort of asset that can be imported and then used in multiple different levels. Let's see. There's a couple different volumes and really nice things for starting off projects. Let's see if I can find the blueprint sky sphere. So when I drag this in, it's going to adjust what that the background color looks like. And essentially what this sky sphere does is it creates this big dome around your world that based off of the directional light kind of adjusts what the daytime looks like. So if I grab, I hook that directional light up into the sky sphere, I can adjust some of the different values here for brightness or speed. Or I can go into the atmospheric fog and reduce how sunny or foggy it is in that sky sphere. So you can kind of see. And you can kind of just play around with that a bit. There's a lot of different volumes that are really nice and useful. If you're looking for kind of like foggy effects, there's exponential height fog, which essentially makes this really, really nice. It's hard to see because I don't really have very many assets in here. But if I drag this way off into the distance, I don't know if you can really see that. I don't know if that comes through. I don't know how well the resolution is for the screen sharing, but there's a little bit of fog between. There you go. I bumped up that density and you kind of see there's a bit of fog now in front of that object there in the distance. That's really nice. And Another important thing when we're talking about lighting is post-processing. And so there is this post-processing volume. So essentially, it's a volume that allows, it reads in all of the current information about lighting and stuff like that. And this allows you to kind of make adjustments to it. An important thing with post-processing volumes is by default, they're set to just the size of the volume you've created. So this is the only area inside this volume that would be affected by this post-processing volume, and only if the player's camera was inside this volume. So if I was outside of this volume and we changed, some of these values in here, I would not be able to see the difference in that area. I would have to go inside that volume. But if I go down here to the bottom and I select infinite extent, essentially this post-processing volume will affect the entire world. And I guess just to give you a little bit of a, to show you like what this is, let's see, I could maybe do, I don't have a dirt mask, but I could probably just adjust, let's see, let's do some colors. So just adjust these values. I don't know if you can kind of see that, but it's changing the color of the world. But if I change that post-processing volume and I go back to that infinite extent, it won't do that until I am inside the volume. So you can kind of see that. But that's what a post-processing volume is. We can use this for other things like if you're trying to get that nice depth of field and that kind of like blurriness in the background, you can also use that here. Same thing. You probably won't be able to see it very well because I don't have any objects in the background really, but that's how you do it. But yeah, I think that's pretty much about all the things that I think are super necessary to talk about for the level design and different stuff. I think a lot of level design and a lot of using these tools is a lot about just playing around with the stuff that you have here and just kind of seeing what it all does, because there's absolutely so much of it that it's hard to go over every little thing. A lot of the level design, the basic level design stuff was also talked about before in the first intro to Unreal video. We're talking about these different buttons up here and what they do, and like snapping things around by holding V on your keyboard, that kind of thing. You guys have any questions? Okay. I think that pretty much concludes the basics for building out a new level, throwing in some new assets like lights and volumes and some basic blueprints there, and creating your own materials and stuff like that.
Yep, that was good. I just want to add a few things. Like Ben said, this is definitely the best way to practice stuff. This stuff is actually practice. And I think specifically for the lab, this stuff becomes even more important to know like in depth and have like a good understanding of, since we do so much VR development. You'll see a lot of the times in PC games and stuff, since it's a more powerful computer, you can kind of get away with some easier stuff. You don't have to fake it as much. Like you can use dynamic lighting, you can use like a lot of opacity and materials. But you'll find when you do a VR project, especially for mobile VR, it helps to have a good understanding of all this so that you can know where to make a lot of trade-offs and how to fake things, I guess, is a good way of putting it.
Yeah, make everything as efficient as you possibly can.
Yeah. But that also just comes from practice too. And so that's the most important thing with all this stuff is practice.
Yeah, I think that's one of the things I really hope you guys notice the most from the videos that we're making you guys look at and watch is there's absolutely so many resources out there on YouTube or on the Unreal documentation website about all these different kinds of things. And it's really just like up to yourself on how much you dive into it and how much you really want to learn, because it's everywhere. Um, the information is there. The YouTube has a ton of it. Um, yeah, just go watch the videos.
And if you ever see something in a project you don't understand or haven't seen, look it up. It always helps. Even if it's like you're not going to mess with it, it helps to, you never know when you're going to be on a project or something's just like not performant and you're like, oh, well, I've seen this before, and you can come
Right.
back and use it. So always try to learn the most as much as you can. It will pay off eventually.
Yeah, I agree. I think the more that you know personally in terms of like broadly and breadth is very useful, because then it allows you to do more stuff, and things don't have to go between this person and this person and this person in order for it to, you know, hit the final stage. You could do all three of those things. Um, Whereas, like, if you didn't know materials or didn't know texturing, if you were building out the level, someone else would have to come in and make the materials and textures for you. Someone might have to import that stuff for you. But if you just know how to do all that kind of broad stuff, um, you know, we can just condense that into one person and
Yep.
speed up the process.
All right. So does anyone have any questions before we stop the recording? Nope. All right. Sounds good.